Now let's discuss about the next type of operation, that is intersection of two sets. Okay, so the next one is intersection. See, what we mean by intersection, or whenever you understand the word or whenever you come across the word intersection, what exactly does that mean? Okay, now union was what? We combine the two sets, the two elements of two sets together, correct? And then we write everything together. That is basically union. Now, whenever we talk about intersection of two sets, intersection in the sense it's the common terms between the two sets. Okay, for example, suppose if I have a set A, let this be 2, 4, 6, 8, 10 and 12. Assume. And say set B is 3, 6, 9, 12, 15, 18. So assume that these are two sets, set A and set B. Now, what are the common elements between the two sets here? Now, when you consider this, see, 6 is a common element, 12 is a common element, correct? So there are two elements which are common for both A and B. So what we write is A intersection B. In the sense here, A intersection is given by this symbol. It's the opposite of union. A intersection B. So this is nothing but, in our case, it is 6 and 12. Because there are two elements between the sets A and B which are common for both of them. So this is what we call as intersection of two sets. Fair enough? Now, whenever we talk about intersection, how we represent this over a Venn diagram? Because that's very important, right? So if you are writing in terms of the Venn diagram, then we have, so first we have two sets here, and then you're going to have the universal set here. Suppose say this is set A, say this is set B. Now the common between them, so the common one, basically this. So this part what we are looking at is basically A intersection B. Okay, so here this part is A intersection B. Got it? This is how we write intersection. Or whenever we talk about common terms between the two sets or two or more sets, there can be 3, 4, 5, n number of sets. The common, whatever you have in common, that is given by the intersection. Fair enough? Now, intersection, union, these two we had learned. Now, let's discuss about certain properties of intersection. Okay, now before the properties, what if two sets have nothing in common? Okay, for example, say you have set A. Let's say set A is A, B, C, D. And set B is suppose say 1, 2, 3, 4. Now, do you see anything common between set A and set B? Nothing, right? So here, these two sets, suppose if I represent over a Venn diagram, this is going to be set A, this is going to be set B. So this is A, this is B. There is nothing in common between them. Or we can write that A intersection B is equal to 5, null set. Okay, now these type of sets where the intersection is 0, or you can say intersection is null, empty set, they are what we call as disjoint set. Disjoint set. So disjoint sets are those whose intersection is a null set. That means there are no elements common between the two sets. This is what we mean by disjoint sets. Fair enough? Now let's look into certain properties of intersection. So under the properties, so there are few properties just like union what we discussed in the previous video. Very simple properties are there. Okay, now first one is the commutative law. That is A intersection B is equal to B intersection A. This we can represent very easily over a Venn diagram. Okay, that means suppose say you have, see this is A, say this is B, say this is the Venn diagram. Now what we have here, this is A, this is B. Now the common part, so this is nothing but A union B, sorry, A intersection B, correct? Since you have this as A intersection B, A intersection B, B intersection A, it's the common area, isn't it? So it is commutative. Alright. The next property is associative. Okay, in associative, when you have A intersection B intersection C, this is equal to A intersection of B intersection C. It is associative. Quite obvious that this has to be associative, because if you logically, if you guys think about it, the area has to be common for A intersection B intersection C, and same thing goes for the other case also, correct? Logically, it has to be true. So the first one is commutative, second one is associative. The third property is with respect to the null set. Suppose if you have phi intersection A or A intersection phi, this is going to be phi. The null set. Null set has nothing, it's an empty set. Empty set and a set, whenever we take the intersection, the result is going to be phi itself. Okay. The fourth property, suppose when you have universal set intersection A or A intersection universal set, this gives you A itself, because universal set contains A. So when you do intersection of the universal set and A, you're going to get A itself. Let's do it over a Venn diagram. Very easy to understand. Now here what you have, you just have one set. So this is just one set, which is A. This is the universal set U. Now universal set and set A, if you take the intersection, you're going to get this itself, correct? This is nothing but what? A itself. That's why universal set intersection A is always A itself. Okay, now let's go for the next property. The fifth property is what we call as the idempotent law. That is, A intersection A gives us A itself. Just like remember how we did for union, same way A intersection A is also equal to A. Okay, this is what we call as the idempotent law. Fair enough? Next, the sixth one is the distributive. So here, let me just write out the name for this one. So this is what we call as the idempotent law. Okay, the next one is a very, very important one. We are looking at the distributive law. Okay, here when we say distributive, we talk about distributive of union over intersection or intersection over union, both. Alright, so what we have is, suppose when you have A union B intersection C, this becomes A intersection C union B intersection C. Okay, so this is distribution of union over intersection. The other way is also correct. That is, if you have A intersection B union C, when you have A intersection B union C, then you'll get A union C intersection B union C. Both the distributive laws are true. Both of them will hold good. Okay, so these are the two distributive laws what we have. That means in intersection, we have over 6 properties, of which most of them are the same as what we have for union, except for the distributive law. Correct? We have commutative, associative, and the intersection with the null set and the universal set. Then you have the idempotent law. Then you are going to have the distributive law. So all 6 of them, they are the properties of intersection of two sets. In the next video, we'll discuss about different types of sets.